Hi boys and girls! Today we're going to be going over ratio quiz number 2 for class 621. Question number 1. Jasmeet wants to paint her room pink. To make the shade of pink that she likes, she needs to mix 2 pints of white paint with a quarter pint of red paint. If she has 12 pints of white paint, how much red paint will she need? So the information in the problem tells us she wants to mix 2 pints of white with a quarter of red. So here we're setting up our ratio table. White has 2 pints and red has a quarter pint. The other information that's given in the problem is that she has 12 pints of white paint. She needs to mix a certain amount of red to make the shade that she wants. So ideally we're making a ratio table to go to 12 pints of white, and we need to find how much red would be needed for that. To fill in our ratio table, we're adding 2 across the top for the white paint each time we make an entry, and for the red paint we're adding a quarter each time. So a quarter plus a quarter is 2 quarters. 2 quarters plus 3 quarters is 2 quarters plus a quarter is 3 quarters, and so on until we get to 6 quarters or 6 fourths. 6 fourths is not an option in our answer choices, unfortunately, so we need to change our improper fraction to a mixed number. To do that, 4 goes into 6 one whole time with 2 left over, and it's still fourths, the pieces. So now we have 1 and 2 fourths. That option is still not there, so we need to reduce this by dividing 2 by 2 and 4 by 2. So it becomes 1 and 1/2, which is choice D. Question 2. Which ratio has the same value as 5 to 12? You'll see on all of the options here I've already written 5 to 12 above each ratio so that the first numbers match up and the second numbers match up. And I've also written in here the multiplicative relationship or factor that each was multiplied by. So if I look at A, on the left hand side 5 is being multiplied by 3 to get to 15. 12 is being multiplied by 2 to get to 24. Since 3 and 2 are not the same, these are not equivalent. Part B, 5 times 5 is 25 and 12 times 4 is 48. The factors are not the same, so these are not equivalent. Over here, 5 times 12 is 60 and 12 times 12 is 144. So in this case, our ratios are equivalent. Let's double check the last one. 5 times 5 is 25 and 12 times 12 is 144. So those two are not the same factor. These are not equivalent. So it's choice C. Number 3. What relationships can you identify in the ratio table? You've already noticed on the left I'm adding by 2. That's our additive relationship on the left-hand side. On the right-hand side, we're increasing and adding by 6 each time we move down a row. And moving from the left to the right, we're multiplying by 3. So now let's look at our answer choices. Part A, the left column has an additive relationship of adding 6. That's not true. We discovered the left column is adding by 2. Part B, the right column has an additive relationship of adding 2 to the previous number. That's not true. We discovered it's adding 6. So B is not true. C, the multiplicative relationship is multiplying the left column by 3 to get to the right column. That's true. We stated that earlier. Left to right is multiplying by 3. It can't be choice D, all of the above, and it can't be none of the above. So it's choice C. Complete the ratio table. If I'm looking at the ratio table, going from 12 to 24 increases by 12. However, there's a box in between there, so we need to look for the halfway point between 12 and 24. To do that, I could do 12 divided by 2, which gives us 6. So I'm increasing by 6 each time. 18 has to be the midpoint between 12 and 24. If I move backwards, that means I'm subtracting 6 from 12 to get to the box above it. That's 6, and below 24 is 30. And that clearly looks like we're following a pattern of increasing by 6 each time. On the right hand side, going 9 to 15 we've added 6 to it. Again, we want to find the midpoint of it. To do that, we're going to divide by 2 again. 6 divided by 2 is 3. That means we should be adding 3 to each box. So 9 plus 3 is 12. 12 plus 3 is 15. The pattern follows. If I'm moving backwards, 9 minus 3 is 6, and 6 minus 3 is 3. And clearly on the right-hand side, it follows the pattern of increasing by 3's or multiples of 3's as we move down. Question 5. Compare the ratio tables. List the lightest shade of orange to the darkest shade of orange. Show work and explain how you determined your order. Well, I'm going to look for the multiplicative relationship because if I'm looking at my tables, there are some common pieces of 6 yellows for A and B, but I don't have a 6 in mix C. I do have a 12 between B and C though, and I have a 4 between mix A and C. It really gets too complicated to try to compare all 3 tables in that manner, so we're going to find the multiplicative relationship, which makes it a little bit easier to work with. So I notice from the yellow paint to the red paint in mix A, as I move down, I'm multiplying by 2. And that relationship holds true all the way down for each entry in my ratio table. So that means if I have 1 yellow paint, there's going to be 2 red paints. For mix B, I notice the yellow paint times 3 gives me the red paint in every single entry in my ratio table here as well. 12 times 3 is 36. That means if I have 1 yellow, there's going to be 3 reds. For mix C, I notice that each time I'm multiplying the yellow paint by 4 to get to the red paint. 12 times 4 is 48, and 16 times 4 is 64. So that means if we have 1 yellow, there would be 4 red. So now that we have the same amount of yellow for all 3 mixes, we can compare how much red there is to each. The less red that is added to our mix, the lighter the shade of orange. Now here comes our explanation. When all mixes have the same amount of yellow paint, 1, the mix with the least amount of red is the lightest. Mix A has 2 red, mix B has 3 red, and mix C has 4 red. So A is the lightest, then B, and last C is the darkest. I hope this helps. If you still have questions, please see me in class. Have a good day.